In this video, we will discuss feature types and measurement levels and how they impact your map design. You'll learn much more about spatial data types in week 3, but for now, remember that spatial data can come in several different types: points, lines, and polygons. These types of data can be displayed on a map based on how they are measured: nominal, ordinal, interval, or ratio. Data at the nominal level means that we know the name of something. Data that is noted by different names or categories are measured at the nominal level. For example, land types, boundary lines, and other data that is produced by assigning observations into unranked categories. Data can be grouped into categories by type, but not ranked from high to low. For example, if we look at the agricultural or land types, we may have a type of orchard, desert, forest, or water. Any of these areas would be a different type, but no one has greater importance than the other. This type of information is not ranked, it's just categorized. Ordinal categories are ranked or ordered by category. These are not based on a numeric value, rather they are an indication of hierarchy or importance, but they are considered to be subjective in nature. One reason for this is that we may know that one is greater or larger than the other, but we don't necessarily know by how much, because it is not based on a numeric value. It is subjective. If we look at the difference between a regional and national and international airport, we know that an international airport may be larger than a regional airport, but by how much and at what interval may not be known or may not be easily measured. Some examples of data that are classified hierarchically might be political boundaries. Transportation routes can also be categorized this way. For example, you may have a primary highway, a secondary highway, and a light-duty road or unimproved road. Again, we know that there's a ranking between these items, but we don't necessarily know the interval between them, or we can't easily measure the interval between them. If we know the interval between these types of data, we're now dealing with interval data. This ranks phenomenon according to a numeric value and is quantitative in nature. However, a very important point about interval level is that the zero value is arbitrary on the measurement scale. The most common example of interval data would be temperature data, because temperature data has a zero that's arbitrary. It's not an absolute scale. What this means is that we cannot perform complex calculations on this type of data, and we'll see that in the next few slides. Ratio data ranks phenomenon according to numeric values that can be mathematically manipulated. Ratio data are also numerical and quantitative in nature, but the zero is not arbitrary. Ratio data has an absolute zero. An example of this may be area. We can measure the area, and then we can also compute differences between different areas. Because ratio data represents positions along a continuous number line rather than members of discrete categories, they're also amenable to analysis using statistical techniques. Ratio data are higher forms of data, and they allow us to do a lot more complex analysis. How you display your data on a map is an important part of cartography and map design. We can see from this graphic that if we had nominal data for cities, we would display the cities with a simple point. However, if we had ordinal data, For example, whether the city was small, medium, or large, the point or graphic may be larger depending on the ordinal value of the city. If we have information about the population of our city, then we can also display that information on a scale based on the actual population number. Measurement levels are also important to us because they provide guidance about the proper use of different statistical, analytical, and cartographic operations. At the nominal level, we can say that A is or is not equal to B. We can also perform counting operations and say something is present or absent. With ordinal level, we can make a judgment and say that A is greater than B. However, how much greater is not known. We can subtract and find the difference between two things with interval data, like changes in temperature or elevation. Ratio level data opens a wide variety of operation choices and can be used to represent many types of measurements like precipitation, density, square footage, and yield. We cover this very important topic here because understanding data types, how they are measured, and what you can do with them is vital to making wise cartographic choices, as you will see in the next video this week about map design.